All right, let's talk about getting started with Rust on AWS Lambda. The goal here is to get you up and running with some seriously high performance, super safe serverless functions in like the next few minutes. Let's do this. So, you're building a serverless function, and you're thinking, it needs to be fast, like blazingly fast, and safe. When every single millisecond of that startup time, the dreaded cold start, really matters, a language that's interpreted at runtime like Python or Node.js, well, it might not cut it. And that's exactly where Rust on AWS Lambda shines. Seriously, it's a powerhouse combination for building serverless apps that are not just fast, but also incredibly reliable. Okay, let's really get into it. So why on earth would you pick Rust for your Lambda functions? Well, it really boils down to three big things. Just raw performance, that famous compile time safety, and this really cool concept called a provided runtime. Okay, so this provided runtime idea is super interesting. See, unlike Python or Node, Rust compiles all the way down to a single native binary file. That means you don't need a whole language-specific environment managed by AWS. Nope, you just hand Lambda your compiled code and it runs it on a bare-bones, OS-only environment. The result? You get insane performance and ridiculously low cold start times. But hang on, before we go any further, there's a really important heads up, and this comes straight from the AWS docs. The official Rust runtime client, the thing that makes all this work, the Lambda runtime crate, is still officially considered experimental. It's awesome for playing around with and for personal projects, but you've got to be aware of this before you go and deploy it to a mission-critical production system. Just keep that in mind. All right, with that in mind, let's actually build something. We're going to use this amazing command line tool called Cargo Lambda. It makes the whole process, creating, building, deploying, just incredibly smooth. Getting your project set up is just dead simple. First, you install the Cargo Lambda tool. Then, you run one command, Cargo Lambda new, and it scaffolds out a whole new project for you. All the boilerplate is just done. Finally, you just CD into that new directory and you are ready to start writing code. Now, let's crack open the code and see what makes it tick. We're going to break down a pretty practical example, a function that gets some JSON order data, creates a little text receipt, and then saves that receipt right into an S3 bucket. So when you look at a typical Rust Lambda function, you're almost always going to find these four key parts. You'll have a struct that defines your input, the main handler function where all your logic lives, some kind of integration with the AWS SDK, and then finally the program's main entry point that kicks the whole thing off. First things first, the implic. You just define a plain old Rust struct that matches the JSON you're expecting. And here's the magic. You add this little macro on top at derive, deserialize, serialize. And this incredible library called Serde just automatically handles all the work of turning that messy JSON into your clean, type-safe struct. It's so efficient. Next up is the absolute heart of your function, the handler itself. It's an async function, and it takes just one argument, this event. And this shows off a really cool feature, the Lambda event wrapper. It doesn't just give you your data, it also gives you the whole invocation context, full of useful stuff like the request ID. Now, inside your handler, you're probably going to need to talk to other AWS services. So here, we're just initializing a config for the AWS SDK for Rust, and then creating a new S3 client from it. After that, you can just call SDK methods like you would in any other modern Rust app. It all feels very natural. Okay. We've written the code, it looks good. Now, how do we actually get this thing from our computer up into the AWS cloud? Well, this is where that Cargo Lambda tool really becomes your best friend. I mean, look at this. It's literally two commands. First, Cargo Lambda build-release. That compiles your Rust code into a super optimized binary that's built specifically for the Lambda environment. Then, Cargo Lambda deploy. That one command packages it up, creates the IAM role for you, and deploys the function. That's it. It's that easy. But of course, maybe you've got existing CI/CD pipelines, and you prefer using the standard AWS tools. You can absolutely do that. You can have Cargo Lambda just build the zip file for you, and then you can use the good old AWS CLI or the AWS SAM CLI to handle the deployment part. You've got options to fit whatever workflow you're using. So you're deployed. Now let's just quickly cover a few essential best practices to make sure your Rust functions are not just fast, but also robust and easy to maintain over time. Okay, this first one is huge, especially if you're coming from the Python or Node world. With those runtimes, you'd use Lambda layers for shared code. With Rust, the strong recommendation is Don't. Just avoid layers. The Rust compiler is so good at optimizing and bundling everything you need into that one single binary that layers just add complexity and can actually hurt your cold start times. And here are a few more rapid-fire tips. Try to keep your core business logic separate from the Lambda handler itself. It makes unit testing a million times easier. Always initialize your SDK clients outside the handler. That way they get reused across invocations, which is a big performance boost. Use environment variables for things like bucket names, and always write idempotent code so you can safely handle duplicate events without messing things up. Now for logging. You can just use a simple println macro, and you know what? It works. But for anything serious, you'll probably want to use a crate like tracing. This lets you create structured, JSON-formatted logs, which makes searching and analyzing them in CloudWatch way more powerful. So when you step back and look at it, Rust lets you take this highly optimized native binary and deploy it directly to a minimal OS. You get incredible performance and safety. And that really leaves us with a big question to chew on. Is this model, this idea of native compilation, the real future of high-performance serverless computing? Something to think about. Thanks for watching.